Hello guys, so today we'll be focusing on an important problem called single element in a sorted array. Now, in this you're given a sorted array consisting of only integers, now where every elements appear twice except for the one element which is occurring only once. Now you have to return the single element that appears only once, and we have to do that using log of n. Now let me tell you one thing. There are a lot of things, there are a lot of articles, YouTube videos which have tried to explain this. But what I'm going to present over here is going to be completely innovative, and trust me that the reason I chose this approach is because during the interview you're always going to mess up because once you go behind an approach which requires handling of lot of edge cases, it's going to be very complicated to implement the same thing during the interview, and handling any failure will become very difficult. So that's why I presented a problem with a this is a common problem which is asked during the interview. The next thing is that the solution which I'm going to present is a very short solution, but the majority of the time which we are going to spend is just going to understand what is going to happen over there. Now, this must be very clear to you that since this question actually requires to us in solve in log of n, we need to do a binary search. I don't think so. We need to discuss over here that. Let's try to understand one thing. So note guys, I'm going to tell you one crucial observation. Let's say that there was no single element over here. Everything was sorted. I always like to think like this only. Life was going good. Everything was just a pair. Everyone had a pair, right? So these are what array of I, and let's try to write their indexes. Let's try to write their indexes. And you might be thinking that, hey, why this guy is doing this? Let me tell you that. The index will be of 2 will be 0. You will start from 0. And again, this 1, 2, 3, 4, and 5. Can you guys note one observation? You can take a pause over here. And can you pause the video and note down one important observation for the pairs? You can pause. Okay, I'm assuming you have resumed. So the one important observation over here is that all the elements of the starting pair their indexes are even based. Their indexes are even based. Look at this. Look at this. They are even based. Now you might be thinking that, hey, what is the stupid thing you're telling me? But wait a second. Let me introduce you. Now, let's say that now I put a single element. Okay. Now I put a single element over here, and let's say that I put 5 at this point. What will be the index of 5? This will become 6. And now after that, let me put all a pair element. So let's say that I put 8, and their indexes will be 7, 8, and so on. So note guys, these are the indexes. Right? Don't confuse it. So these are 9. So now can you tell me what is, you can take a pause over here. And my question is that if I have introduced a new element, if I have introduced a new single element, what is the observation from this point onward? What will be the indexes of the starting pair over here? You can take a pause. I'm just resuming. Now, what can eventually happen, guys, is that all the pair starting index of the pair will be shifted, and it will start from an odd base indexing. Earlier, it was starting from an even base indexing, right? Earlier, it was starting from an even based indexing, but right now it is moved towards an odd based indexing. And this is a very crucial observation which is going to help us implement a binary search algorithm. So basically what we are going to do here is that we are going to make a binary search based approach based on this odd based indexing, and you might be very intrigued why. Now let me ask you one thing. Let's say for some reason, this is how I was thinking. Let's say for some reason a mid was over here. Mid was over here at 7 point, right? So one important observation I can make over here. If array of mid, array of mid is equal to array of mid plus 1, where do you think the single element is going to lie? Obviously, from the screen, you can see that it lies on the left hand side. But don't you think that reduces the search complexity for us? That reduces the search space for us, right? Because if this 7 or 8 are equal, that means no element is going to lie. Like the no single element is going to lie on the right hand side. This becomes very apparent, right? This becomes very apparent. And this can happen, guys. I mean, right now mid is not here, but we can eventually write some element over this side, 10, 10, and we can shift our mid towards this end, right? We can shift our mid towards this end, and the indexes for these will be 11 and 12, right? So right now you might think that, hey, don't you think that mid should be okay? Let me ask you one thing. What will be the mid over here? Ideally, how will you calculate low in a binary search? You calculate mid via this thing, low plus high divided by 2. Now you might be thinking that, hey, this guy is stupid or what? He is telling me that to calculate mid like this. So 0 plus 12 divided by 2 will give me 6. And ideally, I should be focusing on the 6th element, this one element. But guys, try to understand. Guys, try to understand. We are doing a very intuitive ways approach. We want to reduce our search space and we want to shift towards that inside. We are not telling you that we have found the single element. What we are telling is that we are using a binary search to converge towards the side which has the single element, to converge towards the side which has a single element. So now I will give you one more thing, right? I will give you one more thing. If the mid, let's say that, uh and then this thing over here is that the mid should be odd based, right? Mid should be odd based. So I know that low plus high gives me 6, but I will increment my mid to mid plus plus, so that it moves towards this side, and then I can make a crucial observation, right? And the reason I'm making this is because after introducing this 5 element, after introducing this single element, all the elements on the right hand side will have their indexes upshifted. Earlier they were starting from an even based indexing. Now they will start with an odd based indexing, right? They are starting from 7, 9, 11, right? So if I can tell that for the odd based indexing, if the values at the next mid plus 1 are equal, values at the mid plus 1 are equal, that means ki this is a valid pair. This becomes a valid pair. And the single element will lie on the left hand side. My single element will eventually lie on the left hand side. So eventually my high should be reduced to mid minus 1. High should be reduced to mid minus 1. And my low will be over here itself. Low will not get affected. It will be as same as the previous value. So this was the whole intuition behind this given algorithm. And the thing is that what you might ask me, what, hey, now we have reduced our search space. We have reduced our search space and we have moved towards this side, right? Now, the new side which I'm going to introduce, let me erase something for you guys so that it becomes very apparent for you and it's not very confusing. And let's start focusing on this part, right? Let's start focusing on this part. So remember that, guys, we have to find in log of n. Okay? So we are already at each step. If we are already reducing the search space by half, then it's more than sufficient for us to tell. So again here what will happen is that again here mid will be 0 plus 6 divided by 2 and mid will be 3 and mid is odd. Okay? So and try to understand, guys, try to understand. If my mid is odd, this thing will return false. I mean, I will not even go down this path. Okay? You might tell me that, hey, why are you not going down? What I mean is that this check will fail. The earlier check which I written now, this check which I written for the mid, array of mid is equal to array of mid plus 1. This will fail because 3 plus 3 is not equal to 4, right? We are comparing, our mid is here, our mid is over here. Remember, guys, our mid is over here and we are comparing it with 4. So 3 and 4 are not equal, right? So we'll not go down this check. But you might think that in that case, what we should do? In that case, what we should do? Now think about it. Think for yourself. If I know, okay, we already know the answer is towards the right hand side, but how do we actually converge towards the right hand side? So we know that if the is mid is an odd based one, right? Mid is an odd based one, and now I will try to compare with the previous one. If if it is equal to mid minus 1, array of mid is equal to mid minus 1, that means my search space is on the right hand side. The search space will be here. So effectively, I'm telling you that my answer will not exist over here. My answer will not exist over here. I'll cancel this. My answer will be somewhere over here. My answer will be somewhere over here. So that's where we converge again. We try to converge again. Now try to understand. Again, we will try to calculate the mid, right? We will try to calculate the mid from this point again. So 4 plus 6 divided by 2 gives me 5. And mid is perfectly over here. Mid is perfectly over here, right? Mid is at 4. Now, you might ask me that, hey, now what we shall do? Now try to understand, guys. Once we again we compare this thing and the current mid with mid minus 1. We compare mid with mid minus 1. And we know that this pair is equal. So that means कि this the left hand side का सारे लोग valid है. जो left hand side लोग है ना वो सारे valid है. तो मेरा आंसर किस साइड पे लाई करेगा, राइट हैंड साइड पे. सो अगेन आई विल डू इज दैट आई विल शिफ्ट टुवर्ड्स द राइट हैंड साइड. बेसिकली आई विल, देखो एक चीज मेरा क्लियर हो गया कि मेरा आंसर लेफ्ट हैंड साइड नहीं है. तो अब लेफ्ट हैंड साइड नहीं है तो मैं अब क्या करूंगा, लो को कहाँ लेके चले जाऊंगा, मिड प्लस वन पे लेके चले जाऊंगा. लो को कहाँ लेके जाऊंगा, मिड प्लस वन पे लेके चले जाऊंगा. अब मेरा हाई भी ऑलरेडी मिड प्लस वन पे है ना. And since both of them are equal, our convergence will break. Like we will exit out of this while loop and we will return the answer. So yeah, that's all, guys. That's all about this given question. Let me code it for you. इसलिए मैं बोला था कि क्वेश्चन में कोई जान नहीं है. The only Jan is in the explaining that given approach. And convergence, my guys, remember this thing. Whenever you're converging now, do not write less than equal to. Okay? That means you're not converging, you're just checking the mid values. Okay? This is a crucial observation. Whenever you're trying to converge, do not mix the concept of the traditional concept of binary search. That will create a lot of confusion for you guys. So always try to think whether I want to converge or whether I'm going to find the element. If you want to find the element, then this approach will not work. This approach is based on the fact that we want to converge towards the given side. So now trying to understand if mid percentage is equal to 0, if mid is even, I will even write it as mid is even, then mid plus plus. Else if, ठीक है, else if लिखना है यार, if array of mid is equal to array of mid plus 1, तुम ही बताओ कहाँ पे लाई करेगा अपनी वैल्यू, कहाँ पे लाई करेगा. ये वाला केस है, ठीक है. ये वाला केस पे आ गए तो मतलब हाई की वैल्यू क्या हो जाएगी, अब हाई की वैल्यू मिड माइनस वन पे जाएगी. देखना हमने क्या बोला है कि अगर 8 और 8 एक दूसरे से इक्वल है, ऑड पीस इंडेक्सिंग पे है, और मिड की वैल्यू और मिड प्लस वन की वैल्यू, मिड की वैल्यू और मिड प्लस वन की वैल्यू इक्वल है, तो मतलब अपना वैल्यू कहाँ रहेगा, अपना आंसर कहाँ रहेगा, लेफ्ट हैंड साइड रहेगा. तो हमें हाई को क्या करना पड़ेगा, हाई को करना पड़ेगा मिड माइनस वन. एल्स एल्स आप सीधा ये डाल दीजिए मिड प्लस वन, एंड आप फाइनली क्या रिटर्न कर दीजिए, नम्स ऑफ लो. सो ओ लेट मी करेक्ट दिस. This is nums of लो. ठीक है, let's try to see if this code run or not, or if I have to handle any corner case. So this code obviously works, and this is a very minimalistic based approach. And yeah, that's my take on this problem. I hope you guys enjoyed it. And as you can see, काफी minimal है, कुछ ज़्यादा handling है नहीं इसमें, and you can exactly come up with this approach during the interview. So thank you guys. I hope you like the video. If you have any doubts, please let me know in the comment section. See you again.